University, who's going to be participating in the AIDS meeting just this afternoon. I want to start by asking about your background because Ernst Mayr suggested that many naturalists started very early in their careers. How about you?
Yes, I think I was a dedicated naturalist at a very early age. Really, I began not exactly in the South, but right here in Washington, D.C., where I came with my parents as a 9-year-old. My father was a federal employee. We came up from Alabama and spent some time here before he was reassigned back down to Alabama. And during that time, I had close exposure to the National Zoo, which was a few blocks from where we lived, Rock Creek Park, which was kind of a miniature urban wilderness, and the National Museum of Natural History, which I visited with reverential awe from time to time. And those implanted in me the idea that nature was a wonderful thing not only to experience, but to study, and maybe even someday make a career of. I thought maybe I might someday be a Department of Agriculture entomologist. Back in the South, I experienced, of course, a far richer fauna and flora, a lot more nature, with easy access in the small towns that I lived in. And then I had the passion for butterflies, which I developed by that time. And that just one thing piled upon another, and I never looked back.
You left the South to get your education. Where did you go to do your studies?
I began serious study as a scientist when I was admitted to the University of Alabama. Thank heavens for the University of Alabama. It's a very good regional university, and it was the tuition and expenses were low enough so I could go. In fact, I was the first member of my family ever to attend college. After 4 glorious years there of courses in many subjects, but above all continuing my studies of now evolution, entomology, ecology, and generally natural history. I was admitted to the University of Tennessee for PhD studies, stayed there in Knoxville for a year, and then was invited to apply to Harvard. That was partly due to the fact that Harvard has the largest ant collection in the world, and I definitely wanted to study ants. That's what I'd settled on while I was still at the University of Alabama, where, incidentally, as a 19-year-old senior, I did the first thorough survey of the imported fire ant, which was just beginning to spread out from my hometown in Mobile. In fact, in 1942, when I was 13 years old, surveying the ants of my neighborhood, collecting all the different kinds and watching them, I had encountered the imported fire ant not far from the dock area in Mobile. And that is apparently the first record of that important pest species in the United States, and I made it when I was 13. After a year, as I said, at the University of Tennessee, I went on to Harvard and entered a new world there, where I got a more traditional, broad PhD training, continued field work, was given a very cushy postdoctoral fellowship. Actually, I got it even before I finished the PhD in Harvard's Society of Fellows, which gave me a salary, money to support my research, and complete freedom. So I took off from there very quickly to where I always had wanted to go. which was the Mobile River Delta writ large, namely the rainforest of the world. And down I went to Cuba, then to Mexico, and gloried in what I like to call the big tropics, especially, where you get a maximum diversity of insect and other life. And thence 2 years later, while I was still in the Society of Fellows, actually 1 year later, to the South Pacific, where I worked for a year, or almost a year, down from Fiji and New Caledonia to Australia and then up to New Guinea, exploring mountains there, collecting ants. I was the first real collector of ants from New Guinea, and it was quite a life-forming experience. So that was really the several stages, the booster and the secondary stages that launched me into the orbit I wanted to reach, which was a full-time career hunting bugs.
Sounds like a wonderful life.
Mm-hmm.
I know that you were very prolific during this period. What kind of personal traits do you think allowed you to explore so much and be so productive?
I guess I have been fairly productive through my life. One was the great advantage of working on ants, because ants are everywhere. And once you get into the tropics, it's true now, but it was true a fortiori then, that everywhere you look there were ants no one had ever studied before. Some of them with fabulous social habits and beautiful anatomy and so on. So when I got into areas that had been poorly studied, then everything I touched seemed to turn to gold in terms of original research. But in addition, I am a workaholic. That helps.
You kept this focus on ants, and it still is your organismal focus. But you've expanded to examine a number of other topics. Why were you so interested in these other fields? What drew you to them?
My talent is in synthesis. Each scientist has certain talents well developed and other talents not so well developed, and of course that's true of every person in every walk of life. And in my case, I soon discovered that I was not good in languages. I was adequate enough to learn German and French to read the literature. I was mediocre in mathematics. It was a struggle for me to, even in my late 20s and 30s, to get on into calculus and other subjects of intermediate mathematics that would make me literate, or semi-literate anyway, in mathematical modeling and science and biology. But my gift was that of a naturalist and as a synthesizer. And that means that I soak up information wherever I am, especially out in the field, in natural environments. Soak it up like a sponge. I can't stop looking and watching and gathering and taking notes. And then I can't stop looking for patterns. I look for patterns in what I see, similarities, principles out of what I'm experiencing, and that then leads to synthesis, that is bringing very different bits of information and concepts in alignment, or discovering that they are discordant, looking for the reasons why they're discordant and trying to fill it or acquire other parts that can fit in. So it's a kind of intellectual jigsaw puzzle solver that makes synthesizers. And as a consequence, I always had a tendency to broaden, to think laterally, because that's what I was good at, for one thing. I enjoyed it enormously. And starting with ants, I had a great advantage I didn't realize at the time. in addition to their being so abundant and so rich with information to present to you tied up in a ribbon. Ants are social. They're highly social. When I began doing research on ants, serious research in my teens actually, there were so many things fundamentally we didn't know about the social behavior of ants, including how they communicate and the full nature of their social behavior, what the caste do, why they're a caste, and so on. And as a consequence of studying these phenomena very closely in my 20s and 30s, I began to think about the need for a new synthesis of our knowledge of social insects, ants, bees, wasps, and termites generally. At that period, I had now entered into another field called population biology, which is you don't hear the expression nearly as much as you used to, but that's part of the foundation of evolutionary biology, the study of ecology and of evolutionary process and so on, but quantitative, based on demography and the age distributions and the growth patterns and other properties of populations. And I realized that insect colonies are not just colonies, they are populations, and that you could apply many of the ideas and techniques of studying population, including demography, to the social insect. And that was just the beginning. There was also the principles of population genetics, which were becoming honed to the point that we could do theory on the origin of social behavior with the aid of population genetics. The new idea of kin selection was just taking hold at that time. I saw the enormous possibilities there. And so my first big synthesis, no, it was the second big synthesis. The second big synthesis I did was in 1971. That was the insect societies. And that's where I proposed the idea of a discipline of sociobiology, which would be a systematic and synthetic study of all forms of social behavior in all kinds of organisms upon a base of population biology, genetics, and ecology. And I might add in passing that before that, the first synthesis I did was also came from ant studies originally in 1967 with the ecologist Robert MacArthur. I devised the theory of island biogeography, and I have to sort of back up like an oxbow bend in a river and come around again to say that part of what I did in the study of ants was to work out biogeography. There's a distribution of species of ants, and I became even as a student, but then as I worked in the South Pacific, enamored of the idea of faunal balance, an equilibrium of species and genera and families, and of the notion of dominance. This had been originated by earlier biogeographers. That is, that as one big group works its way in from one continent to a group of islands, or from one continent on to another continent, you know, like the old world over to the new world, that usually something gives. If the other group, the invasive group succeeds, the other group retreats, and very likely that has some kind of equilibrial quality. In other words, life can only generally be so diverse. There's a maximum level of diversity. And in the South Pacific, I had taken that idea and worked it out at the species level, which had never been done before. And out of that came exact formulations of the relation between the number of species on an island, you know, like New Caledonia or the small islands around New Guinea and the like, and the number of species that are found sustainably on each of these bodies of land. And I also used, in looking at this, data from birds, and also data from reptiles and amphibians that had even been published to show that there was apparently a regular relationship. And on the basis of this notion of equilibrium, of balance, MacArthur and I worked together and produced the theory of island biogeography. He produced a central famous crossed curve model, increasing extinction rates as you increase the number of species on an island, decreasing immigration rate as you deplete the number of species that can make it over as colonists. So where they meet, you have an equilibrium, very simple but basic idea. And that had become an important part of ecology and population biology by the time I got around to this synthesis in 1971. The insect societies was really the beginning of sociobiology. But encouraged by its success, I then decided to expand it to vertebrate animals. And I thought that would be very difficult to do because a lot had been published on vertebrate social behavior up to that time. But I found it was strikingly easy to do, particularly since I got something I hadn't really expected, which is the full cooperation and help of experts on vertebrate social behavior. They were delighted to have someone include their work. I've discovered over the years that as long as scientists are given credit for their work, and it's quite clear that you're going to celebrate their work, which is what scientists should be doing if their work is sound, then they love you. And there's a very good reason for that, and that is that originality and credit for discovery are the silver and gold. They're the coin of the realm of science. That's what scientists live for, to discover, to have the exhilarating experience of discovery, to publish it, and to be given credit for it. That's their whole life. Everything else is incidental. So I discovered that because I do enjoy so much crediting other people, and showing how their work comes together and celebrating each discovery in turn, I got a lot of very prominent collaborators on this, and then by 1975 was able to publish my next major synthesis, which is sociobiology, subtitle The New Synthesis. And that went over very well, most of it. In fact, the animal part, which is the bulk of it, of the book, was voted a few years later by the officers and fellows of the Animal Behavior Society as the most important book on animal behavior of all time. Even beat out Darwin. This was in the 80s. A lot of people have asked me, why didn't you leave people alone? But I had in this book to deal with human beings as well, because after all, we are an animal. We are a species, a social species, and as exalted as we think ourselves to be, and in fact, I suppose, relatively speaking, we are. We actually have animal origins, and our social behavior is very likely to be subject to the same kind of principles fundamentally. It occurred to me that, in fact, human nature was explainable by principles of sociobiology that also applied in varying degrees and bits and pieces to the lower animals. Of course, that created a lot of controversy because it turns out that the social sciences in the 70s, the people didn't believe in any kind of biology and human social behavior. It was all history and accident and culture. And this ran directly counter to their tradition. They were afraid of social Darwinism, which is understandable, and the Marxists as well, which were prominent on the campuses in that time. In fact, it's hard to see now or remember for those who weren't intellectually mature, that is, grown up and aware of happenings in the academic world at that time, just how prominent leftist philosophy and particularly Marxist philosophy were. And this idea of any biology involved in the course of cultural evolution is anathema to the Marxists. So I had a lot of problems. But without going into it, because my main passion is natural history after all, I'll say that over the years, human sociobiology, also called, nowadays frequently called evolutionary psychology, has become mainstream. You're likely as not to find it on the cover of Time magazine or the feature article in the New York Times, and it's just part of the culture. So that seemed inevitable to me in the 70s. I just couldn't see how the human brain could be put together like an all-purpose computer, a blank slate, a tablet of wax on which the completely blank, in which you've inscribed the culture, and that's what made a human being. Human beings are far more than that. We have a profound biological nature which makes us distinctive and gives us individuality. At any rate, the point is that was by the year 2000, which we have been so fortunate to reach now. That opposition has faded away, and it's now mainstream. I'm glad I lived long enough to see that happen.
I remember those days.
Oh, you do?
Yes, that's when I was in school.
My goodness, I have to compliment you by saying I never would have suspected it.
I was in school in the 70s, and I remember these discussions.
Yeah.
I think it must have been a disappointment to you to find a scientific pursuit now pushed into a political, social arena.
Yes. Yes, it was. It was a bit of a surprise, because I was rather naive in those days politically, to find that a subject could become so heavily politicized. It was never meant to be political, and in fact, those who did research on sociobiology from the very beginning, including human sociobiology, were rarely, if ever, had political agendas. What they had was ambition. They saw that there were important discoveries to be made. But the critics, I think it's fair to say, did have a political agenda, and it colored very strongly the way they reacted to the whole subject. Not many scientists, but a few. And that was a surprise and a disappointment.
You went on in the 80s to work on biodiversity and define the term. Mm-hmm. Talk about those days.
Well, I always had more than one ball in the air, and among them was working out with a few colleagues. I started this actually in the 1950s. Some of the chemical communication of ants. We were able to find out how ants communicate. That was quite a satisfying set of developments. 15 or so classes of chemical substances passed out as pheromones from glands all over the ant's body, and to be tasted or smelled, and then biogeography, and almost simultaneously the aspects of sociobiology, and then always running through this, and island biogeography, always running through this was an intrinsic fascination in biodiversity, what we call biodiversity, short for biological diversity. And by the late 70s, of course, I'd known all my time working in the tropics that the tropical rainforests were being cut to pieces. And I and others were aware that something really bad was happening to the natural environment, especially in the tropics and most of biodiversity. But I had this idea up to the 70s that there were outstanding organizations, non-governmental organizations such as World Wildlife Fund and the Nature Conservancy and the International Union for the Conservation of Nature. They were looking after these matters and doing whatever could be done. And furthermore, the federal government, maybe I had gotten an unsupportable faith in the federal government during my childhood years here, were capable of handling matters of this magnitude. But by the 70s, I realized that no, as valiant as some of these efforts were, they were not enough, and that the scientists who know about biodiversity, we didn't call it that then, it was biological diversity, should get involved, and I did in the 80s, and so I became something of an activist myself, but not, I hope, a politically ideological activist. This is a non-partisan issue, this matter of declining biodiversity and the extinction of species. So I've been deeply involved in that ever since, and I'm on the board of directors of several of the major organizations devoted to the study and pursuit of conservation of biodiversity. In 1986, here at the Smithsonian, we held the first biologists and others interested in the field, related environmental science field, held the first national forum on biodiversity. I didn't invent the word. That was invented by the group from the National Research Council who helped organize it and initiate it. They wanted to shorten biological diversity to biodiversity. And when they invited me to be the editor of the volume, I also had the lead article. I at first said, no, that's too glitzy. You know, people wouldn't like that. Scientists wouldn't like it. But they said, no, we think that really would, make it distinctive and it would catch on. I said, okay, that's fine. So that was my contribution. I was the editor of the first book on the subject, and I don't think there's been a scientific term ever that spread around the world and came into current use and entered the ordinary vocabulary of the world faster than biodiversity. Fortunately, it did take a jump up after the forum, biodiversity did, in public consciousness, but not nearly enough. And now in 2000, we're far, far from being at the level of public understanding and commitment to reach the magnitude of effort we need to save the world's biodiversity. So now I spend a lot of time writing on this subject. I published, for example, The Diversity of Life in 1992, which has served as a kind of standard text on the subject. And I'm writing another book as we speak, and giving lectures at not every opportunity, but on many occasions, and working with others. And at this stage, I'm beginning to think that maybe there's enough awareness of enough people around the world, and enough who have the political and economic clout to actually bump the effort up for global conservation to the level where we actually could staunch the hemorrhaging of species by extinction to some extent, maybe to a considerable extent. So that really is what's ahead.
In this meeting and your more recent work has been about integrating different disciplines of science.
Mm-hmm.
Would you end our interview by talking about consilience and the integration of different kinds of scientific efforts?
Yes. Well, the incorrigible synthesizer in me has never been able to stop. So, and particularly because I work on the outer edge of biology, which is sociobiology, where we're dealing also with human social behavior, I saw early on, as early as 20 years ago, when I published On Human Nature, the book On Human Nature, that a synthesis of what we call the great branches of learning, the natural sciences, social sciences, and the humanities, might be in the offing. If we could get networks of causal explanation feeding up from the natural sciences as they had done from physics to all branches of biology, to unite them, this having been completed in about the last 20 years, would it be possible, the logical question was, that this mode of explanation could be expanded on up to include cultural behavior and human social institutions, at the foundation of which is human nature, at the foundation of which in turn is biology. It seemed like a reasonable proposition. And I thought that there's lots of lines of evidence to indicate that is the case, and it would be a fruitful line of investigation. So I revive the term consilience with an S in it, which had been used off and on